Hello everyone, it's March 27th. Alright, let's get it going. Minimum cost for tickets. Plan some train traveling. One-day pass, 7-day pass, 30-day pass. Passes allow that many days of consecutive travel. Example, if we get a 7-day pass on day 2, we can travel from day 2 to day 8. 2 plus 7 minus 1. The minimum number of dollars you need to travel every day in a given list of days. This is actually a very good question. So, I'm pretty sure this is a DP problem. So just to figure out how to DP it. So we have 1, 4, 6, 7, 8, 20. We can say, if I want to know for 20, right, what's the best, then we can say we can either know the minimum of doing the 8, then we do a 1-day pass, or the minimum of 20 minus 7, right? 20 minus 7 is 13. It's actually going to be 14, right? Because 14 plus 7 minus 1. So 20 plus 1 minus 7, so 14. So we need to see if there's anything for 14. So we need to binary search it. So we get that. And then will be the minimum price of that, then plus a... Yeah, so it has to be at least 14. And then, or plus a 7-day pass. Or 30, 20 minus 30, right? And then we go to the first one. So we do a 30-day pass, right? So that's how we get 20. So we can go from front to end. So for the first day, right? For the first day, the minimum cost is going to be 3 of them. So it will be 2. For day number 4, we can do the previous day. We don't have a previous day. Oh, we can do a previous day. We can do a previous day and the previous day. Hold a second. The previous day. No, we have to go a 1-day pass, right? Which means that will be the minimum of of what we have in the previous, and then we do a 1-day pass, so it'll be 4, or we go for a 7-day pass, right? So 4 minus 7, right? 4 minus 7 is so we actually put a 0 at the front, right? We put a 0 at the front, so 4 minus 7 is going to be a negative value, so we'll end up to 0, so it will be a 7, or 4 minus 30, so that will be a 15. So of course we have 4. Now for 6, we can do a 1-day pass, right? A 1-day pass, which means the just 6 minus 1 is 5, right? What will be the one that's larger or smaller than 5? So it'll be 4. 4 plus 6, 4 plus 2 will be 6, or 6 plus 1 minus 7, so we go to 0, we're still nothing, so that'll be 7, or 15, so we get to 6. Now for 7, right? So 7, so we can have 8, right? Or 7 plus 1 and minus 7, that'll be 1. So we go to 1. And the 1 we find out is 2. So if we buy a 7-day pass, ooh, a 7-day pass, we should not include that one. We shall just minus 7. We shall just minus 7. Yeah, should just minus 7. So that's 7. So actually 7 is the smallest. 15 is still that. So for 8, well, if we do a 1 day pass, it's going to be 10. If we do a 7 day pass, it's going to be 9. If we do a 30 pass, it's going to be 15. For 20, if we do a 1 day pass, it's going to be 12. If we do a 7 day pass, 20 minus 7 is 13. So we search for 13. We actually get 8. So minimum is 9. So 9 plus 7, that's going to be 16. And will be a 30-day pass, will be 15. So that gives me 12. But the answer is 11. Ugh. So I think I got a little bit wrong. No, I think we have to go one by one. One by one. Like 1, 2, 3, 4, 5. Every single one you have to get. That's what I think. Okay, so let's redo this. So 0, right? 1, if we have 2, 3. 0, 1, 2, 3, 4. So this will be 2. Right, this will be 4. If we do this, it'll be 6. If we do this, it'll be 8. Wait, right? Is that right? I don't think it's right. Hold on. On day 1, you bought a 30-day pass. Cost 15. Oh, no, on day 1, you bought a 1-day pass. On day 3, you bought a 7-day pass, which covers all the way to 9. And on day 20, you bought a... On day 3, you bought a 7-day pass, which covers 3 to 9. Which means that'll be $9. Right? $9. Yes, we have $9 on day 8. The best will be $9 because 8 minus 1 minus 7 is 1. So day 8 is 9. Oh, I was right. When on day 20 you look for 8, it's not 10, it's 9, so it's 11. Yeah. Yep. It's just a simple DP problem. Simple DP problem. You sure? You sure you want to go that route? A simple DP problem. DP is never simple. Okay, I take it back. Some DP are easier than the others. This one's actually a good one. I like it. And we need bisect import. Bisect. Is that right? Let me think. Do we want a bisect? If it's the same, we want to have it. If not, I think it should be bisect left, because bisect left will have that thing, right? Otherwise, it will be in front, right? Otherwise, it will be in between. If I have this, then we have in between. Then we need to go -1, right? If I need to start from day 3, but I only have a day 1 and day 4, then I need a -1. So we have to go bisect right. Okie dokie. Costs. That's okay. Cost can be, is days sorted? Days is strictly increasing, so day has already been sorted. Costs, that's fine. So what we need to do is a DP 0 times land days plus 1. So let's go n equals land days. Okay, and this will be n plus 1, right? Okay, okie dokie. So what we need to do is days. We need to... That is okay. We just need to... The whole point is... So we'll make it easier. We'll make it easier by prepend as 0. So days equal to 0 plus days. And we do this. Okay. Then we say for I in range 1 all the way to n. And then for each one, what we're gonna do is for j for cost, for d, the cost in zip. Okay, costs, not days first. So we have 1, 7, or 30, and costs, right? And we say dpi shall equal to minimum, right? dpi, ooh, this has to be math.infinite. And dp0 need to equal to 0. So this and what? And we are going to do cost, right? Cost plus something, which is dp something. What is that something? That something needs to be an index, which comes from bisect right. Why don't we just do j equal to bisect right? Well, bisect right days, and we're gonna search for days I minus day. Okay, so this will give me j, and this is just gonna be dpj. I will do this, and then we'll return dp minus 1. Let's give this a shot and see if it makes any sense. So this one shall be 11. This one shall be 17. Okay, this one's 17. All right, so we have days, costs, minimum costs, days, costs. I do not like it. Okay, something is not right. Because this has to be j, has to be minus 1. There we go. We forgot a minus 1. My bad. Alright. I think this shall be good. We can actually write it. I have confidence in this one. 983. Not binaries. DP with binary search. Actually, I'm not that confident. We can do 1. Maybe. Oh. Has to be strictly increasing. I don't know. Putting some weird stuff. Costs. Wait, what? Oh, I forgot the costs. Actually, we can actually do something like this, right? And just play with this. That'll be fun. Oh, this is fun. This is gonna be fun. Days must be increasing. What did I do? 77, 88, 99. Oh! What the hell? I did not expect this to be wrong. My. Holy crap. How did this one get wrong? 1. Now I need to fix this. I go 15, 2, and 7. Answer shall be 2. Right? I got 15. That is not right. But I did take into consideration all of this. We start from the first one, right? And days, I go 1, 7, 30. And we say j equals binary search days, which is just 1. And days just is going to be that's going to be a negative value. Ooh, a negative value. A negative value. So if it's a negative value, it's going to end at 0. And you're -1. That is not good. Don't think that's how it's supposed to be. Wait, hold on. Let me think. If you minus d, right? And then you got a negative day. And a negative day is guaranteed to be pointing to 0. Right? It's pointing to 0, which means if it's going to be 0, so I think it should be like this, right? So if j is equal to, is larger than 0, j minus equal 1. Aha. That. Try that. It's a 0 thing. Now we're talking. Now we are talking. Now we can submit. We've done it before. Many times. 998. 998. When? Log n. You want to see how you did in the past? This probably is an easier standard solution. Oh. Ah, I see. No need to binary search and a handle of. Oh yeah, why do you binary search, right? Because the days, okay. No need to binary search because the max amount of days is only 365. We can literally list every one of them. Okay. Then we say is dp, right, shall equal to dp shall equal to every single day. So we shall go 0. Now there's still math.inf times days -1, that many plus 1. And dp0 equal to 0. Okay, and then day set equals set days. And for I in range 1 to days minus 1 plus 1. Okay? So that's every single day. You say if I is not in day set, dpi shall equal to dpi minus 1. Else, I'm going to do this for the costs, right? And we say dpi shall equal to the minimum of dpi and cost plus something. What is this something? dp something. That shall be I. I is the day, so I minus day, but maximum of I minus day 0. Then we will return dp minus 1. Let's try solution 2. Solution 2 seems to be good. We just list every single thing. Looks good. Is good. So this will be O max days. Alright, so that's that. We handled it. Why didn't we like it last time? 2020. Wow, it was a long time ago. Okay, so now we have to come here and check the hints. Create two frequency maps and find the minimum element among all elements of both arrays. Minimum element. Check if the sum of the frequencies in both arrays is odd. If so, now we've done that. Store the elements that need to be swapped in a vector and sort it. That's, we have swap 1 and swap 2. Can we reduce swapping cost with the help of minimum element? Yes, we can. Oh, yeah, that's my min v. Calculate the minimum cost of swapping. Are you telling me this is the right way to do so? That was O(n) log n for me. That was very short. That's my idea. But that's really fast and really short. Yes. Yes. Put all the elements of the two arrays that need to be exchanged together and sort them. Choose the first half as the costs. Okay. Choose use direct exchange or indirect exchange. Each time according to the situation, because the choice of which number is free, the smallest number in the two arrays can be greedily selected as the intermediate. We're now going to use a quick slice for this. So I think what it says is, if we find all the values that need to be swapped, like all of them that need to be swapped, then we lay them out. We laid them out. So if we have like some of this need to be swapped there, some of this, so we can just lay them out, and then we just iterate through. Because first half, so we say, okay, I'm gonna swap this with somebody on the other side, and there's always gonna be a one-to-one correlation. So if this, so I think all we need to do is, now we counter it, that's definitely needed, and then we need to get all the values that need to be swapped. So we get 2 counters, I think that's fine. And then we get the value out. If the 2 are not the same, we get how many. So let's do this. Let's try to see if we can make this one better. Okay, solution 2. Inspired by same idea as solution 1, but we don't have to simulate the swapping. All right. We just need to collect all the values that need to be swapped in a single array, sort it, and treat the first half as costs. We'll go through them one by one and use it if it is smaller than 2 times main value. Once 2 times main value is smaller, we can break and use the mean value for the rest of the swap. So we'll still have to do this. We still need the 2 counters. I do think we still need 2 counters, right? But what I think is we can go through, have the combined counter. We do this still, but we just say swap. It's gonna be a single array, okay? And we say for v in this, we can do swap. We can say if these are not the same, swap dot extend, right? V times this. Of course, ABS this. And we'll sort the swap, get the mean value, get the rest. Then we say for s in swap the first half. Right? We get the first half. If 2 times the mean value, we need the I in enumerate. Might as well just say for I in range len swap divided by 2, right? Then we say if this is smaller or equal to swap I, then we'll break. Otherwise, rest plus equal to swap I. Blah, blah, blah. I'm going to break out, return rest plus the remaining. So we go to I, right? This one we need to swap, but we cannot swap. So how many swap we need to do? We need to do len swap divided by 2. That's the total number of swap we need to do. And then we have done I already. So minus I, that's the remaining we need to do. So we will do this, multiply by 2, multiply by minimum v. I think this might simplify it. Okay, that is not correct. Let's handle this. Okay, don't worry. Let's get print swap. Let's get what are the swaps? So we need to swap 1 and 2, right? Okay, we swap 1 and 2. And for I in range 1, so 0, I is 0, the swap is 1, and 2 times this is minimum 1, that's 2, smaller equal to 1, no, so rest plus equal to 1, so we have 1, and then we break out, and then rest times, so I, I think if you want to use that, I think it'll be better if you use a while loop. Okay, I plus equal 1, that will pass. Now we can try the others, and they will all pass. This way the logic is much simpler. No, the implementation, right, is much simpler. Okay. Yep. Better. Much better. So yeah, we did get the right idea. So that's always a plus. Alright, that will be it. I'll see you guys tomorrow.